so Beyond Design Studio, we do a lot of construction and interior design services for residential construction. So I currently use AutoCAD. I definitely am interested in an introduction to some sort of 3D drawings, but also just sort of brushing up my skills on AutoCAD or computer-aided drafting, which we do a lot of for the most part with all of our construction drawings. And I also have my children who they're 9, 11, and 13, and they're always interested in the work that I'm doing in my business. And so I like to slowly start teaching them about computer-aided drawings.
Okay. Hi, children. What are your names?
So we have Julia, Lucas, and Antonio.
Okay. Hi, guys.
Hi. Hi.
And girl.
Hi.
Hi. Okay. So I'm sort of trying to draw it out a little bit, but that's okay. It's like Zoom meetings. I guess, where are you guys, Cindy, where are you located, by the way?
I'm in Tiburon.
Tiburon. Okay. I'm in Tiburon also.
Oh, okay.
So I guess we're all in Tiburon because it's or at least nearby.
Close by,
so,
yeah.
Yeah. So my background, I have a degree in physics, and so I had a career in physics, and I taught for many years at the university, and after that I did a lot of software design and programming, and I've always had sort of hobbies of machining, 3D printing, sort of maker type hobbies that I've been doing pretty intensively for the past maybe 5 to 7 years. And I mainly use SolidWorks, which is why I included it on the curriculum. I'm most familiar with that. But of course, SolidWorks is an expensive program, and as is AutoCAD. Let me see, I just want to make sure I can share my screen, first of all. I want to see what happens when I do that. Let's see. So if I go share screen, looks like I can choose my screen and I can go share. So do you see a big colorful table of things on your?
Yeah.
Okay.
Yep, that's good.
So this is a Wikipedia page of all the different CAD design programs that they listed. And there's probably a lot more than even on this list. But I hope it doesn't make you dizzy, but I'm just like scrolling down to show you how many there are. And a lot of them are free, a lot of them are very expensive. And they all are a little bit different. I mean, I obviously haven't tried every one of these. But if I go down the list, I can find the ones that we're going to be doing with. So right here is Tinkercad, and that's by Autodesk, which is the same as what you're probably using, Autodesk.
Right.
So it's the same company. It's just sort of their free version for hobbyists. And if I go up to the next one, next week we'll be talking about SketchUp.
Oh, great.
Which is, I guess it was originally by Google, I'm not sure, but now apparently it's by Trimble has it.
Yeah.
They have a free version and a pro version of SketchUp. And I have a friend who's a carpenter that just uses SketchUp all the time, free version. It does everything it needs it to do. And I'm most familiar with SolidWorks, which is sort of engineering oriented program. And you can draw things in SolidWorks and send them out to the machinist to be machined or 3D printed. And it's very powerful. So I think by the next few weeks, we'll see the similarities and differences between these programs. And maybe you'll get a feel for which one you like to use or which one you'd go to for a particular kind of project. So today, it's Tinkercad. And Tinkercad, it's interesting to read the history of it. I remember when they first invented it, and it was designed, to be really super easy to use for people who don't have a lot of experience with CAD programming. And then, according to their information, they were founded in 2010, and they were bought by Autodesk in 2013. And that sounds like a pretty big success story to me. I don't know how much Autodesk paid for it, maybe quite a bit. So Tinkercad, if we get started with this, the first step is to go to the Tinkercad website, which is tinkercad.com, and get an account or sign in with Google or Facebook. And so I want to make sure everyone has their Tinkercad account or is logged into Tinkercad on www.tinkercad.com, and that you're looking at your dashboard. So I guess I'll give you a few minutes to make sure that you either can log in with Google, Facebook, Apple, Microsoft, or you create your own account, Autodesk account. So when you're there, just raise your hand and say aye.
Okay, we're there.
Okay.
Aye.
We're good. This is Brian, by the way.
Hi, everybody. Jumped in.
Okay. And Cindy, you have a?
Yeah, we're logged in.
Okay, so everyone's looking at their Tinkercad dashboard?
Yes.
Okay, good. So now it's a cloud-based program, so all the information is stored in the cloud, and it works in your web browser,
Okay.
which is kind of neat. And so the first thing to do, and so before you guys start fiddling around, I'll share my screen and show you. I'm going to click on my Create New Design button, and I want to get into the design space. And then I just sort of want to show you a little bit what the different parts are, and then I'll let you play around within here. So first of all, this big thing in the middle is called the work plane. And it's the default work plane. And if you've done any 3D printing, you can imagine this is like the plane on your 3D printer. You imagine it like that if you want. And so there's a few more things to look at. One is up here. Can you all see sort of my mouse arrow moving around in this area in the upper left?
Mm-hmm.
Okay. So this is the left menu, and it has all of the normal things like copy, paste, duplicate, delete, undo, redo, all the functions you'd expect to see in any Microsoft Word or something like that, or almost any program. And then up here is the right menu, and it has these commands that are specific to objects. Like you can group two objects together, or you can ungroup them, you can align them, and you can flip them. So those are the mirror is what they call it. So those are sort of the common operations you would do on an object. And then on the right, this panel here on the right are what we'll call your primitive objects. And they're just basic objects like boxes, cylinder, sphere, triangle, cone, different objects that you can sort of start with in your design. You start with something close and then you modify it.
Right.
Okay. And so Tinkercad, they call it constructive solid geometry. So different CAD programs have different sort of philosophies about how they work. And Tinkercad works like blocks. You just bring blocks onto your platform and you combine them and you modify the blocks as you want to. But you don't create blocks from scratch.
Hmm.
So that makes it a lot easier to use, but it also sort of limits the possibilities of what you can do, what you can easily do. So I'm going to just take a box and drag it onto my work plane. So now I have a box, and it's selected because I dragged it on there, and there's these little handles here, which we'll talk about later. They have sort of obvious meanings, but I'm just going to click somewhere else to unselect it. And what I want to show you is that you can change the perspective. You can change the angle at which you're viewing the work plane. And you can do this by, it depends on what kind of mouse you have. You can right click and drag like this to change the angle at which you're viewing. Or if you don't have a right clicker on your mouse for some reason, you can press the control key and left click and do the same operation. So you're always going to be doing this to look at your work. And this is one of the most fun parts of 3D modeling.
Yeah.
You can also go over here on the left and you can just click on front or right side or left side or top, bottom. So what happens sometimes, it happens to me a lot, is I'm dragging around and I sort of get lost at where I am. Like I forget if I'm looking at the front or the back or the top or something. So you can always just kind of go back to a particular side. Or you can go back to the home, which looks like this. It's with the work plane thing down here in the front. And you can, using your scroll wheel on your mouse, you can zoom in or zoom out. And you can also do that with the plus and the minus. So you're always going to be doing this kind of thing to inspect your work. Okay, so why doesn't everyone just create a new project and drag something that you like a box or a cylinder or whatever you want, just drag one of them onto your work plane and then just start changing the perspective and making sure you can zoom in and out and see it from different angles. I just want to make sure everyone's comfortable with that.
So what you're seeing is
And if I drag a box and I have an idea of something I want to create, can I, oh, I see it right there, length, width, and height. So I can be specific instead of dragging it. I can.
Absolutely.
And those are inches or feet? Those are.
Well, I have it in the grid is, if you look on the bottom right, my grid's in millimeters.
Oh, I see. I can change.
So you can change it, different sizes, and you can change different units.
How did you go to the units?
I clicked on edit grid.
Oh, edit grid. Okay.
Yeah.
Got it.
So I bet you're usually working in IPS or inches.
Yeah.
Or inches or feet.
Yeah. Okay. Perfect.
Okay. And so I can modify the shape of the size of my box by clicking on it, selecting it. And now I have all these handles and I can rotate it around if I want. Let's say 45 degrees. I just typed in 45. Or I can resize it like this, drag it, make a diamond, different shape. Or if I want to, like I think Cindy said, I can just type in the exact dimension that I want. Like that.
Right.
Okay. The dimensions are always like XY dimensions. So because I rotated it 45 degrees, now I'm sort of going corner to corner. But if I rotated it, if I go back to 0, say, I guess I have to go minus 90, minus 45. And now I can get the sides. So say 20 millimeters and 20. And I somehow still have it askew. So at this point, I'm just going to delete this guy and drag it on. It's because I resized it when it was at an angle, and then I changed the angle back, and apparently didn't like that operation, that order of operations. So that's the X and the Y. And I can change the Z by grabbing this little arrow up here and dragging it up. I'm sorry. I can change the Z by grabbing this little box here and dragging it up and down, or I can set it to exactly the dimension I want. And I misspoke. The arrow up here moves the entire thing off of the work plane. And that's important, an important operation as well. Right now I'm 41 millimeters off of the work plane, and I can set it back on the work plane by entering 0.
How did you raise that off of the work plane?
This little arrow up here at the very top,
Oh, okay.
you drag on that,
Oh, okay.
and then you can set it back to 0 if you want. It's not, if you want to be precise, it's easier to use the numbers, and if you want to be fast, it's easier to just drag things around.
And if your mouse doesn't do the orbiting or whatever you call it, what did you say was Control F?
Oh, hold the Control key down and then click with the mouse.
Oh, I see.
Click and drag
okay,
with the mouse. Yeah.
got it.
Okay. Now there's some more things we can do here, but I'll talk about those in a little while. What I want to do, I think it's, once you have sort of the basic operations, it's easiest to learn from example.
Yeah.
So let me just jump right into an example here. So I'm going to go back to my desktop, and I'm going to draw something, and then I want you guys to try and redraw it. So I'll just take you through it once. So I'm going to draw this nut here. First, I'll show you what the final result looks like. It looks like this. It's just a nut. It's actually an M12 nut. So I'm going to start from a new design and redraw that from scratch. And after I'm done with this, you're going to have a pretty good idea about how this thing works. And it won't take very long unless I screw up. Okay, here's a new blank workspace. And I want to draw a nut. And I actually have the exact dimensions. I want to draw an M12 nut here. So I'm going to refer, and this is just, you can get the specifications for any kind of hardware easily on the internet. I just happened to go to this engineersedge.com page. And this is the one. I want to draw something that looks like this up here, more or less. And this M12, these are the dimensions that I'm going to be using. So the width across the flats is 18 millimeters, and the thickness is 20 millimeters roughly. It's something like that. So I'm going to use these specifications or something close to them in my design. So I want to draw a nut. So what's the first thing I should do? Is I should start with something that's sort of nut shaped, like this polygon. I'm going to drag this polygon onto my work plane. And now I told you that the height, if I refer back to my specifications, M12, the height is 10, the thickness of the nut is 10 millimeters, and the width is 18 millimeters. So I'm going to make the height, what did I say, 10? And I'm going to make the width 18. Now, I also have to worry, because it's a hexagon one width is from flat to flat. That's in the X direction. But in the Y direction, it's corner to corner. So I have to go back to my specifications here and see the width across corners is about 20.78. I'm just going to say 20.5. So that's the Y width, 20.5. Okay, there. So now I think I have the dimensions more or less the way I want them for the size of that nut.
Mm-hmm.
Now, if you look at it, it has a little bevel. It's not completely flat on the top. There's a little bit of a bevel, sort of rounded at the corners. So I'm going to go back into my design, and I'm going to use, I'm going to do something easy. Is I'm just going to change the bevel here to about that. Just eyeball it. Now,
Oh, that's like the top rim.
can you see this little? Yeah, and the bottom. Yeah. It bevels all the top and the bottom. Okay, so I want everyone to repeat that, and I don't care if you get the dimensions exact or not. I made it 10 millimeters tall and 18 across and 20 from corner to corner. So I want everyone to do this more or less those dimensions, and then put a little bevel on it. And then when you're done, just tell me you're done.
Okay.
Done.
Okay.
Oh, you're fast. Okay, I think I'm there.
Okay. So everyone should be looking at a nut of about more or less 20 millimeters across and 10 high and beveled edges. And so now we need a hole, and we need a threaded hole. So how are we going to do that? And this is where it starts to get really interesting. So on the panel on the right is all of our shapes. And right now we're looking at basic shapes. But if we drop down, we can look at more advanced shapes. And if you search here in featured, one of them is this threaded cylinder. Everyone see that?
Yeah.
Okay, and you can put a little star, click on the little star up here, and it'll save it to your favorite, so you don't always have to go searching for it. And now what we're going to do is we're going to take this other shape and we're going to drag it onto our workplace. And now we have to set some of its properties. So the first thing is that I want it to be 12 millimeters diameter because I'm actually drawing an M12 nut. M12 is metric 12 millimeters. So if I click on it, and you can do this with me if you have enough room on your screen. If I click on it, I have to set the diameter. Well, it just turns out the diameter is already 12, so I'm good there. But the thread pitch, if I go back to my standards here, the thread pitch is 1.75. So it's one thread every 1.75. Or it's 1.75 threads per millimeter, I believe is what it's telling me. So I'm going to change this pitch to 1.75. 1.75. Okay. And then now the segments have to do with like, really it's a complete continuous circle, but in a CAD program, you approximate circles by a certain number of straight lines, straight segments. And right now it's telling me that I have 16 straight segments going around to make a circle. And you can make it higher if you want. It'll be much more accurate, but it'll also be slower rendering. So I think 16 is okay. And now the question is, how long do I want it to be? And so that's in rotations. Right now it goes around 5 times. So if I count the threads, 1, 2, 3, 4, 5, I can make it longer if I want. Say make it 10. Or 10. Now it's 10 threads long. If I want, I can do that. Might as well do that for now. So I have this nut without a hole, and I have these threads. And what do I need to do to combine them to make a hole? I'm going to click on my threads, and instead of it being a solid body, I'm going to make it a hole. So it's like a negative solid body.
Mm.
Now I'm going to drag it onto my nut. And it's going to make a hole in a second. But I want to align it. So this is the next really important operation that we're doing. So I'm going to select both of these items. I'm going to select the nut, and I'm going to shift, select the threads. So now I have them both selected. And I'm going to go up here to my menu, and I'm going to click Align. And this it takes a second to understand how this all works, but notice these dots here. There's 3 dots on the bottom and 3 dots on the sides. Each side has 3 dots. So if I select the middle dot, it's going to align it to the middle here. And if I select the middle dot here, it'll align it to the middle in the other direction, in the Y direction. I could also have selected align it to the edge, and it'll move it down to the edge. But that's not what I want. I want to align both the X direction and the Y direction in the middle.
Mm.
So alignment is a really important feature. So you just learned 2 important features. 1 is turning something into a whole, and 2 is aligning 2 or more solids. Okay, so now I have my 2 solids aligned. They're still separate. And what I want to do is I want to select them all. Another way I can select is I can just drag a box around them.
Yeah.
And I can group them. And then it combines them. And now I have my finished product.
Cool.
Okay, so if I'm going too fast for anyone, just stop me, and otherwise I'm going to sort of go into space.
Good job.
I think we're good.
Okay, good. So, all right, important concepts are the work plane, the primitive bodies or primitive objects on the right panel, and then the operations of combining things. Sometimes you turn something into a whole before you combine it, and it makes a whole instead of adding the solids together. Okay, so let's look at my notes here. All right, so the next thing I want to do, this is going to show you a little bit more complex operations. And I'm going to go back to my dashboard. Let me name this. M12 Net 2. And now I'm going to go back to my dashboard. And then, oh, here's the one I just made. So I can click on that and I can get back into it if I want. All right, so now what I want to do is I want to make, say I just want to make this, it's called a cap screw. Here, I want to make this. I'm sorry if you guys think nuts and bolts are boring, but they're actually pretty instructive. So I'm going to make one of these. So I'm going to start with a new design, and I'm going to try and get suggestions from the audience of what I should do first.
Dragging a cylinder?
Drag in a cylinder. So this is going to be the head of the cap screw. And if I search on the internet, I can find all the dimensions for these cap screws, and I'm making an M12 one to fit my nut. And I see that the diameter, let's see, the head, across the head is A. So A is 18 millimeters diameter, and the height is 12. So if I can remember that on the other tab. So I want to make this 18 in both dimensions. And I want to make the height 12. Okay, so there's sort of my basic shape. And let's go back to what it looks like here. It looks like this. So what do you think I should do next?
Another cylinder?
Okay, before we do that, I'm thinking about the bevel on the bottom. This thing has got a little bevel here. So I want to create that bevel, so I can select the cylinder and I can go to the bevel and I can say maybe make that 2 or something, 2 millimeters. Okay, and so it made my bevel, but it makes it on both ends. And I only want it on one end. So what could I do? Here's where Tinkercad is like sort of, you have to stand on your head a little bit. What can I do to get rid of one of those bevels and keep the other?
You add another cylinder like on top of it and then combine them together as a group.
Yep, that's exactly right. So I'm going to take another cylinder. Actually, let me see if I can just duplicate this one.
I was going to just say maybe you could duplicate and then take the bevel out.
Yep,
One.
duplicate it. So now I have 2. Take the bevel out. Change the height to something smaller than 12. Let's just make it 5. And raise it up a little bit. And now I want to align them. I'm going to select both of them. And I'm going to click Align. And I'm going to align the tops. And I'm going to align the centers. And now I'm going to select them both again, and I'm going to group them. Okay? So now I have that piece.
How'd you duplicate? Was there a quick command for that?
Yeah, I selected an object, and then I went up to my left menu here and
got it.
click the duplicate, or you can go Control D.
Okay.
Now, I don't like the color of this thing. It's a boring bolt, so I'm just going to change the color to some gray. Okay, there we go.
Yeah.
All right. Now, so we have the head, then we have this sort of this part of it that's not threaded, and then we have a part that's threaded. So let's make the part that's not threaded. How do we do that? Anybody?
Sorry,
What was your question?
Sorry? Oh, the question is, how am I going to make the next part of the bolt?
The featured spring or featured.
There's a part that is not threaded yet. So there's sort of a smooth section, and then on top of that is a threaded section.
Oh, got it.
There's a smooth section and then a threaded section. And so I want to make the smooth section next. So
Another cylinder?
Another cylinder, right. So now I want to put the other cylinder on top of this cylinder. So the question is, how are we going to do that? And there's a few easy ways to do that. One is, let's just make another work plane. So I'm going to select this face and I'm going to click on work plane. I didn't need to select it, I guess. I just drag a work plane here and set it on top of that face. So now I have a new temporary work plane, and I drag my next cylinder onto that temporary work plane. And now I'm going to change the size to 12. And the other thing, if I can get rid of it, move it over here. And the other dimension to 12. And I'm going to change the height to 10, let's say. And now, and you can see how it's like sitting on this other temporary work plane. And now I'm going to align my pieces. Select them both. Click align. Align center and align center. Okay. And now I'm going to combine them into a group. And now I want to get rid of my temporary work plane. I just click somewhere. Let's see, work plane.
Oh, yeah.
Yeah. So I selected work plane and I clicked anywhere not on a piece, and it got rid of my temporary work plane. So that was sort of teaching you how you can use temporary work planes in the workflow to make it more convenient. I didn't have to do that.
Can you go over that just one more time very quickly, just of how you got the second work plane in there?
Yes. Let me do it again because we still have to make the threaded piece. So I'll repeat it. I'll repeat the process again to make the threaded piece. So I'm gonna make another temporary work plane on top of the stack that I already have. So I'm gonna click on work plane tool, and then I'm gonna move my mouse over the face that I want the work plane. See how it sort of clicks onto there? I could have moved it to here, it would have clicked onto there, but I want it on top here. And then I click my mouse and it makes that work plane. So,
and David, that's just a quicker, it looks like that's just a quicker way to start building on top of versus creating an object and then trying to raise it and place it.
Yeah, I could have not used the work plane. I could have just put another object onto my default work plane and then dragged it up a certain distance. And I just have to make sure that the distance is correct so that the two faces match up. But I think the work plane is a lot faster.
Yeah.
How did you measure the second portion of that bolt, the smaller section?
You mean the diameter or the height or?
Yeah, I guess both.
Yeah.
See, let me get rid of this work plane. I'm going to click somewhere not on an object, the work plane goes away. So if I select this, so I had them grouped, so let me ungroup them. And so this is the one you're asking about.
Correct.
And so there's these little handles.
By 12.
And if you click on like a corner handle, you can either drag the corner handle or you can directly type into these, click on and type into these numbers here to change the size. And you can change the height by clicking on this handle up here and either dragging or type into the number box. Is that working for you?
Thank you.
I want to make sure everyone is following, because it's easy to get completely lost if it goes too far without you understanding something.
Mine's not perfect, but I'm just learning as you go.
Yeah, it's fine. Okay, so let me regroup these again so I don't mess up. One thing about Tinkercad is that after you align two parts, you can still move them individually unless you group them. So you'll mess up your alignment if they're not grouped. So I'm going to group them. And now I'm going to, should I wait for Brian to get back?
Here.
Okay. Now I'm going to use the work plane method because I find it easier. I'm going to create a new work plane. I'm going to click on work plane. And then I don't have to hold anything down. I just select it. And then I'm going to move my mouse over to this surface, and you see the work plane sort of pops into place. And then I click to drop my work plane there.
Okay.
And now that's a temporary work plane. Anything I drag on to it is going to be on that work plane. And now I'm going to find my threads again. So I actually saved it into my favorites, or you could search for it again in featured, but I have it in my favorites because I clicked the star. So it's right here, thread. So I'm going to drag this onto my work plane somewhere. And it's 12 millimeters. I'm going to change the pitch to 1.75 just because that's the way it's supposed to be. And adjust the height by the rotation. So I'm just going to give it, say, 15 rotations around, just arbitrarily. And then I'm going to click somewhere else, and I'm going to zoom out. And now I need to align what I previously made with what I currently put on the temporary work plane. So I'm going to select them all. I'm going to select, and I'm going to go Shift Select to select both of them. I'm going to click Align, and I'm going to choose Middle and Middle. And now I'm just going to click the work plane tool and click anywhere to get rid of that temporary work plane. Okay, so we're a little bit short on time. There's one more operation we have to do on this thing. And I just want, I'm not going to do it in front of you, but I want you to tell me how it would be done. So the operation I'm talking about is on the head of this bolt, there needs to be a hole for a hex wrench. So if I look on my bolts here, see this hexagonal hole here? It's for an Allen wrench to go into. And the size of that is, if I look on my chart, the size of that is 10 millimeters across. So I need a hexagon that's 10 millimeters across. So, and it's a hole. So how would I do that? I'm looking at the head of my bolt now from the bottom.
Yeah.
How would I do that?
Is there a hexagon basic shape?
Yep. There's a polygon. If I go into basic shapes
Oh, the polygon, yeah.
and scroll down, there's a polygon.
So do you want to do a new work plane underneath of the surface?
Well, I think the existing work plane is already good.
Okay.
But I could do that.
Oh, because you could just stack it on top if you're working on the same plane then afterward?
Exactly.
Okay.
So I'm just gonna change this to 10. And this is corner to corner, so now I don't know what that needs to be. So, you know what so maybe about 12. I'm just guessing now because I'm in a little bit of a hurry, but it's more or less correct.
Okay.
I'm going to change the height maybe to 4 or 5. And then what do I need to do next? 2 more things. One is turned into a whole. So when I combine them, it actually subtracts, it doesn't add.
Right.
And then the other is, oh, backing up. I forgot to group these. Let's group them all. Let's group that. Okay.
Oh, right.
Yeah, because if they're separate pieces, you're going to get messed up when one starts moving around, the other won't move. Okay.
Right.
So now finally I have to select both of these objects. I have to align them middle and middle. And then I have to select everything and group it. And, oh, I made a mistake. I didn't align middle. I guess I clicked the wrong thing. So it's not aligned middle. So let me
Control Z will backspace.
Yeah. Control Z. That ungroups them, and then I want to align. Let's see what I did wrong. Middle. Okay, and then now select everything, group it. And if I did it right, yep, okay, there we go. All right, so from that little lesson, you learned about work planes, temporary work planes, which is really convenient for stacking things. And then we also reinforced the idea of holes and alignment. And to be honest, like that's almost everything you need to know. There's one, okay, so there's one more, oh, okay, 2 more things.
Hey, David, before you go on, can I just ask you a real quick question? How did you get that negative space at the bottom of where your screen is right now? Where the hexagon or polygon, like how did you get that to raise up, recess into that surface?
I mean, why am I looking at it from the bottom?
No, like the shape that you recessed into the bottom. How did you get that negative dimension?
Okay, let's see if I can undo all this stuff here. Okay, so I put that hexagon onto my work plane. This hexagon.
Yeah.
And I turned it into a hole instead of a solid.
Oh, got it. Okay. That was.
And then when it's a hole, it subtracts instead of adds.
Oh, that's important. Okay.
Yeah,
got
it's
it.
really important. Super important.
Thank you.
Okay, you're welcome. Okay, so okay, so there's 2 more things that I want to talk about. I know we started a little late. Is everyone okay to go like till 5 after 5?
Yeah.
Okay. So the first one is I have a nut and I have a bolt. How do I combine them? What if I wanted to put the nut on the bolt? And so let me show you. If I go back to my dashboard, let me show you what I mean. I did this earlier.
Does it save automatically?
Yes.
Okay.
Okay, I deleted what I did earlier, so I'll do it again. So we have here's my nut. This is the nut we just made.
Right.
So I'm going to open it up, and the way you open it is you can go tinker this. And there it is. We made that the first thing we made. Now I'm going to export it. And I'm going to export it to a .stl. This is the same thing you would do if you wanted to 3D print this. So I'm going to save it as a file, STL file. And it's in my downloads. And now I'm going to go back to my dashboard. And I'm going to open the bolt. Okay, here's my bolt. And now I'm going to go import. And I'm going to find the STL that I just exported. Downloads, STL, open, import. Okay, and now let me select them both, click align, align the middles. And then let me just drag this. Oops. I grabbed the wrong handle. So let me just drag this. This is what drags it up.
Oh, I forgot to join these.
Yeah.
No.
So I messed up the alignment when I dragged it by the wrong handle. So I have to select them both again and click align and align them again. Okay. So if you followed that, I know it was kind of quick, but in order to combine two different parts that you drew in two separate Tinkercad drawings, you have to open one, export it as an STL, and then you open the other one and then import the first one into the second one. And that's how you combine two parts.
So if, oh, go ahead.
No, go ahead.
I was just gonna say if the nut and the bolt were the wrong dimensions and I align them, would they actually tweak and figure it out, or do they have to be perfect geometry?
They have to be perfect geometry.
Okay, so okay.
Anyway, that's a little bit. I think that method of combining things is a little bit counterintuitive and not the best way to do things, but that's sort of like one of the limitations of Tinkercad. And if you get into more complex assemblies, it just becomes more and more difficult to do.
That's why this is the free version, right?
Yeah. Yeah. If you're willing to pay $3,000-$4,000, there's better solutions to combining parts. So it's up to you.
I'll stick with this for now.
Okay. Anyway, it's kind of cool. And if you wanted to 3D print something, for example, you would just export it as an STL anyway, and then import that into your 3D printing software.
Cool.
All right. Also, this nut, I want to change its color. Let's just make it black. That's just how you change colors. Something that's not obvious until you see it done once, and then it's obvious.
Yeah.
So select the object. Inside the little solid thing is where you can change the color. Yeah. Okay. So all right, moving on. There's one last concept I want to introduce. And that's this ruler tool up here on the right. So that's useful for in certain situations. So let me go back to my dashboard. And suppose I wanted to make a block. Let me wait till it loads up here. A block with 4 holes. Pretty common thing to do. But you have to be able to, like, you can imagine how to do it. You start with a box, and then you put some cylinders in it, but the cylinders have to be turned to holes. And then you have to place the cylinders where you want them to be. And that's, if they were simply aligned, like aligned to the centers of something, that would be easy to do with alignment. But right now I'm sort of placing them without aligning them. They need to be placed in a particular location. So I'm just going to rebuild this from scratch. So you'll see what I'm talking about. So let me make a new design, create new design. And the first thing I'm going to do is I'm going to click on the ruler tool and put a ruler onto my work plane. And now that ruler is going to help me position things. Now I'm going to put a box. I'm going to change the dimensions of my box. Let's just make it 100 by 50. And let's make it 10 tall. So there's my box. And you can see that what the ruler does is it shows you, it's measuring where the corner of the box is compared to the origin of the ruler axis, compared to the circle. So I'm just going to make those both 0, 0, and 0. So my box is sitting right at the origin of my XY axis. Do you see how I did that?
Yeah.
Okay, if I drag this away, it's going to show me, in addition to the length, width, and height, this is the height, this is the width, the length and width. Mm-hmm. There's these two other dimensions, which are the distance from the origin of the ruler that I stuck on there. So I'm going to just make that 0, and I'm going to make that 0. So the ruler is, the box is sitting at the origin of my rulers. And next, I'm going to take a cylinder. Let's just make it 10 by 10. You can't, even though it's round, it doesn't let you set the radius. You have to set the X and Y dimensions. And then I'm going to make it into a hole. And because it's a hole, I don't care about the height as long as it's higher than my box.
Right.
And now I'm going to position it using the ruler. I'm going to put it at, instead of 0, 0, I'm going to put it at 10, 10. And then I'm going to duplicate it. I'm going to take that cylinder. I'll just drag another one on.
Yeah, but is there a way to freeze your ruler so you don't accidentally drag your ruler on your work plane?
No.
Okay.
Not that I know of. It's the way you drag it is by getting this round dot here. So just don't drag that dot.
Don't drag the dot.
Yeah. I'm going to just get another cylinder, 10, 10. I'm going to turn it into a hole. And then I'm going to place it with the ruler. I'm going to place it at 10, and I'm going to place it at, this was 100. The block was 100 wide, so I'm going to place it at 90. Is that right? No. Ah, okay. Aha. So this is a little trick you need to know. When what the ruler is measuring is measuring the distance from the origin to the little left front corner.
Oh.
And I want to change that to measure the center of the cylinder. So I'm going to click on, see these 3 lines here?
Yeah.
Use midpoint. There we go.
Okay.
Now it's measuring to the midpoint, and I'm going to go 90. And I'm going to go 10. That's better. And then this one also, this cylinder also, I need to make sure it's using the, okay, it's in use midpoint mode, so I'm going to change this to 10 and 10. Okay, there. Now I have them place them the way I want. Before it was placed funny because I wasn't measuring to the very center of the cylinder. I was measuring to one of the corners. Okay, so instead of putting 2 more on and making 4 holes, I'm just gonna say we want a block with 2 holes. How do I actually make these turn into holes?
Do you merge them?
Select
them?
them. Yep. Merge them all. Select them and group them.
Group them.
Yep.
Oh, okay.
Okay. So that's it. That's it. Those are all the basic operations. And we talked about rulers just now, which are really useful for this kind of placing objects. We talked about work planes, which are really useful for stacking objects on top of each other, temporary work planes. The concept of turning something into a whole before you merge it, that's really important. And the concept of the whole basic concept of how you create things, which is you start from primitive shapes and build it into some kind of shape that you want.
Right.
So final words here. If I look at my panel and I go to my basic shapes, there's all kinds of cool stuff. You can do circuit boards. You can do dinosaurs and skeletons.
Oh, cool.
But you might be interested, Cindy, you might be interested in this one, which is home stuff.
Oh, yeah. I was going to give you the starting point on all that.
Yeah, OMSI Hangout Space. There we go. Don't ask, I don't know what OMSI means, but anyway, it has all these pre-drawn chairs and tables and fun things like that. But all the other principles are the same. You could probably get a couch and put a hole in it if you wanted. You could put a threaded hole into the couch if you want.
Yeah.
Add that bolt to it.
Yeah.
Keep it
Yeah.
fun.
Every leg could have its own bolt. Okay, good. Well, I hope that was clear. I know that you have to actually use this. You don't know it until you do it yourself. I get that. But
Right.
hopefully there'll be a little bell that'll ring like, oh, how did he do that? And then you'll remember it's just the basic operations of turning things into holes, resizing, aligning, grouping, and that's it.
So if we were to spend our time, and I know through the weeks you'll introduce other things, is this a pretty industry standard software? Most people are using this over like SketchUp, or it's...
I don't know. I think they all have their advantages and disadvantages. Like I told you, my friend who's a professional carpenter uses SketchUp. And, I think as we go through it, you'll see what the tools are capable of and which tool is better for which job.
Got it.
So I couldn't make a blanket statement that this is better to use. You have to tell me what you're trying to do. If you're trying to draw a cube in under 2 minutes, I would say this is probably a good one to use.
Right.
But if you're trying to do more complex things like create, curves and fillets and doing things that aren't already something close to a pre-existing shape, then you're going to be standing on your head trying to figure out how to do it.
Got it. And next week is SketchUp, you said?
Yeah, I'm going to go through SketchUp next week.
Okay, great.
And then I'm going to do SolidWorks, and then we have another week. I'm not sure exactly what we're going to do on the last class, but I'm sure it'll present itself.
Yeah.
And so your homework for next week is you're going to show me what you designed in Tinkercad.
Perfect.
Do you guys have a 3D printer?
No.
Okay.
Not yet.
There's not one over in the office at the ranch?
There isn't. I think somebody wanted to donate one, but it wasn't, just didn't work out like that. They do have one at the library though in Tiburon.
Yeah.
So I think it's free to use too. So
It is. It's a nice one, actually.
cool.
Yeah. Ultimaker.
I'll do some tinkering over here and then see if I can go print it over there.
Okay. Well, thank you very much, and look forward to seeing your designs next week.
Yeah, thank you for all the help.
Sure. Okay.
Great. Thank you so much.
Sure.
Bye.
Bye-bye.
All right, bye everybody.